Hi everyone. Today we are going to discuss about Newton laws of motion. First part. In this Newton laws of motion, we'll discuss the introduction. So what cause to move the object from one place to another and what are the different types of inertia? That we'll discuss in this part. Okay. Now the laws of motion. So this is our part one. These will be useful for our state board, NEET, JEE, and CBSE. Okay, now we'll go for the introduction. In this introduction, first, if we observe here the one example, we have ball. To move a football at rest, in order to move the football from this rest position, definitely we have to kick it. Means we have to give some force, some external force we have to give in order to move that ball. That we can observe with the first example. And second example, to throw a stone upward. To throw a stone upward, so definitely here also you have to give someone upward a push. So in order to move upward. Next, some so from these two examples, what we can observe means that we have to give some external agency is needed to provide the force to move your body from rest. Okay, so what we observe with the two examples means if here in first case, if you observe the ball is at rest, and second case, if you observe the ball at rest, now we want to change these two positions from one place to another. Definitely, some external force we have to give the body in order to move from rest. That we can observe from these two cases. Okay, and another third example, if you observe here, we are considering n ball is rolling down an inclined plane and to stop the motion. Now the ball is coming from this inclined plane. In order to stop this ball, what we have to do here again, we force against the direction of its motion. So we have to apply the force against the direction of motion. This is the direction of motion forward. We have to apply the opposite direction in order to stop the ball. Okay, so in these three examples, we observe that the external agency is needed to stop the motion or to retard the motion. A retard means the opposite of acceleration. Acceleration is moving forward, a retardation is it's going to stop. That is the meaning. Okay, the next we will see the another concept. Again, if you observe here the two examples in more detail, a stone is released from top. In previous example, we discussed the stone is going upward. Now the stone is released from the top. And another case, a bar magnet attracts iron nail from a distance. So this bar magnet will attract this iron nail. Even the iron nails will at a large distance. So here, first the stone accelerates due to gravitational pull of the earth. So definitely, just if we release the stone with these two fingers, it will come to the ground with the help of gravitational pull. That is gravitational force. That is M into G. With that gravitational force, the stone will come, and here, due to the magnetic property, the nail will come and attract. Okay. Now, if you have here next, you will see the one point. The external agencies can exert the force on a body even from a distance. Even it is a long distances also, we can exert the external forces. Next one, the external agency may or may not be in contact with the body. Okay, there is no need to contact. Here, if you observe the nail is not contact with that magnet, but even though it is a far distance, due to the attractive property of magnet with respect to nail, it is going to attract. That is the here we observe. And here these two will be in contact, then we release it. It is coming down with the help of gravitational force. The next. Next, with that two examples, what we observe means there will be some property which maintain the body at rest. Okay, so what is that property means? The inertia. What is inertia means? It is inability. It is inability. Inability of the body. Inability of body to change its motion or to change its motion, to change its motion. That is our inertia. That is we call law of inertia. So here we are taking the example. Let us consider a car is moving some velocity v, and in order to move the car, definitely we have to apply some external force. Otherwise, the car is at rest. So if we want to move the car, we have to apply external force, and we want to stop that vehicle. So that we have the frictional force and brakes has to apply. Then the car will stop. And we need an external force to increase the speed. In the same way, in order to increase the speed of the car, we have to apply the external force. So no external force, no change in velocity. That we have to observe from this example. If there is no external force, there is no change in velocity. Means the body is at rest, or maybe it will move with uniform motion. Okay, so that we can observe with this example. The next, law of inertia. See here we have the broad examples to analyze our inertia of motion and what is the inertia main thing. Okay, so inertia means resistance to change. Okay, initially the body at rest, later it is going to change. Okay, but that body does not move, so it is opposes the change of motion. That is only inertia, means resistance to change. If it is initially at rest, means it will be at rest, or initially it is moving with some uniform, means it is moving with uniform. Okay, there won't you won't change. So that is our inertia. And we'll take the example here. A body does not change its state of rest or uniform motion unless an external force compels it to change the state. Someone has to compel the object, then only the object is moving from one place to another. Otherwise the object at rest. Now here if we observe the one example, we placed in ball an inclined plane, so it is coming with some acceleration. Now the ball, in order to move here, it will gain some retardation, means it won't move right up, it will be at rest only. And in this third example also, if you observe, neither accelerate nor retard. This will be at rest until unless an external force applied on the body. So there is no external force, then there is no change in its velocity. Same previously we discussed with the car example, the same example here. What we can conclude main in these examples means there is no external force, there is no change in its velocity. Okay, so that we observe. Now, and again, we'll see the another examples regarding our inertia. What is the inertia and what is the importance of the external force, how it will affect the body. Okay, now we'll discuss in terms of friction. Now we place a object or ball or this inclined plane. If there is no frictional force, what will happen? The ball have the height from here to here. After the same height only, it will reach the ball one end to another. In the second case, if we discuss the here, if we observe the slope is decreases. Even the slope is decreases, the ball is reaching the same height. Okay, this is the final height and initial height is same here, and same way here the ball reaches the same height. And third case, if there is no slope, if there is no slope means the ball will travel directly proportional to the distance. How much distance it will be the same way the ball will travel. Based on these observations, the Galileo concluded that uh, if it is a frictionless horizontal plane, the body travels with uniform velocity. It is a frictionless horizontal plane. Here we are taking the frictionless horizontal plane, then it is moving with the uniform velocity. Here there is no need to give any external force. Even there is no external force, the body tends to move in forward direction in uniform velocity. So that is the important conclusion we got with the help of our Galileo. Okay, the next types of inertia. The now what we discussed till now means what is the inertia and what is the importance of external force. Okay, with the help of external force, how the body will change, that we discussed. Now the types of inertia. In inertia also we have different types of inertia. That is three types we have. Now we'll discuss the first type of inertia. That is inertia of rest, means the name itself, inertia of rest, means the body is at rest, means it is the ability, it is the inability of the body to change its state of rest by itself. It won't change by itself, inability of the body to change its state of rest, that is our inertia of rest. Example, if we take here, the passenger standing on a stationary bus experiences the backward jerk. When they will experience the backward jerk, when the driver starts the bus suddenly. Okay, so just you let us assume you you sit in bus, the bus suddenly move forward. We what will get? We'll feel some backward jerk, that backward check will fail up. Okay, so in this case also our body does not move. It will also remains in rest. See now, see what is the reason? This happens because the feet of the passengers in contact with the bus comes into the motion. Okay, because now here our feet will be contacted to the bus. Now the bus is moving forward direction. That's why we feel that jerk. And but the upper part of the body continues to be at rest. This upper part of body, it will maintain remains at rest. Okay, that is our inertia of rest. Then another example, if you see for inertia of rest, suppose if you take a coin, this example, a coin is placed on a smooth piece of cardboard placed on a glass tumbler. If the cardboard is struck suddenly, now if we apply some external force this cardboard, in this cardboard we placed a coin. In this cardboard we placed a coin. This is our coin. Okay, now what we are doing, we didn't apply any external force on this coin, but we are applying some external force due to this cardboard. Suddenly, the cardboard slips away, but the coin falls into the tumbler. Here in this, if you observe, the coin here is falls to the tumbler. So what is the reason behind of this means? It happens because of inertia of rest of the coin. Because the coin does not move, it will maintain its rest. Okay, it will maintain its rest. That is a inertia of rest. Okay, then now we'll see the another one, inertia of motion. What is that inertia of a motion? It is the inability of the body to change its state of uniform motion. Okay, if the body is moving in uniform motion, it won't change by itself. That inability of the body to change its state of uniform motion is called the inertia of motion. And let us take the example. A body in uniform motion can neither accelerate nor retard on its own. Okay, it won't move forward and backward by its own. Now, the example, if you see the passenger sitting in a moving bus experiences the forward jerk. Now, this example, the bus is moving. Bus is moving, and the passengers are sitting in bus. When driver stops suddenly, the driver apply the brakes. Suddenly, the bus stops. Then what will happen? Definitely, will experiences a forward jerk. Definitely, will move forward. So, what is the reason? Means that is the inertia of a motion. Means if you observe here, this happens because the lower part of the lower part of these passengers in contact with the bus comes to a rest along with the bus, but the upper part of the body continues to be in motion. This upper part of the body is continues to be in motion, and the lower part of the body at rest. Means that is the inertia of motion, the inability of the body to change its state of uniform motion. Okay, even the bus is moving with some uniform motion, and suddenly apply the brakes, it won't change. Okay, that is our inertia of motion. Next, another third one, the inertia of direction. Inertia of direction. So what is our inertia of direction? Inability of the body to change its direction of motion by itself. Means the direction it won't change by own. That is our inertia of direction. A body continues to be move along the same straight line unless it is compelled by some external force to change it. Otherwise it will be, it remains constant only. Okay, for this we'll take the example. We'll take the small solid sphere connected through a string rotating in circular motion. This is the one string connected to one solid sphere in circular motion. A string continuously apply the force on the sphere towards the center. That spring continuously apply the force towards the center. The force helps to change the direction of motion of the sphere continuously to keep the circular motion. Now here we are applying the force on the string. It is changing its continuous motion and it is maintaining it in circular form, like same way here, here, and here, and here. That is inertia of direction. So if the string snaps suddenly, the sphere moves tangentially to the surface. Suddenly string snaps means it will move tangential. Okay, that is inertia of direction. Or another example, if we take while you are going to the bus sudden turn will be taken. So we'll feel towards left or right. That is also the inertia of direction. Okay, then. So these all our different types of inertias. Next class we'll discuss Newton, first law, and what is the applications, what are, where we'll use the Newton laws. Thanks for watching and subscribe, like, share, and comment. Thank you.